So far we've looked at two different ways to represent proportional relationships. We've looked at a table and we've looked at graphs. And today we're going to look at the last one, writing an equation. So the idea with an equation is that we describe the general way that the two quantities are related, how the input and the output are related, and specifically what we are doing to the input to get to the output. So first of all, we're just going to look at a few tables that don't necessarily have a context, but they do have a relationship. So when I look at this first table here, I can see that the point 0, 0 is in the table, which means that it's going through the origin. So that's a hint that this may be proportional. To check the rest of the points, I need to do y divided by x. That's 5 divided by 4. 15 divided by 12, which when we simplify it by 3 is 5 divided by 4. And then I'm thinking that this is probably times 5/4 as well. Let's double check and make sure that that also fits the pattern. That's 2, that's 11, that's 55 halves, which is 27.5. So 22 times 5/4 does equal 27.5. So therefore, we know that y divided by x is always 5 divided by 4, or 5/4. So a reminder that what this means is that we're always multiplying x by 5/4 to get to the output, y. So in general, we could say that regardless of what number I put here, I'm always going to follow the same operation, which is multiplying by 5/4. So no matter what x goes in the input, I'm going to multiply it by 5/4 to get to the output, or y. So if we state that in terms of an equation, x times 5/4, or as we write it, 5/4 x, always equals y. So what are we always doing to the output? To the input to get to the output? We're multiplying it by 5/4. So 5/4 times the input, represented by x, always gives us y, the output. So here's the second example. I've got a for my input and y for my output. And again, we want to know the constant of proportionality because we want to know what we're multiplying a by to get to y. So let's take a look. I see this line of the table has a y divided by x value of 1 divided by 3, or 1/3. I see that this line of the table has a y divided by x value of 4/12, which also equals 1/3. Here I can see that 2 times 1/3 equals 2/3, and here I can see that 10 times 1/3 also equals 10/3, which means that my constant of proportionality is 1/3, which means I'm always multiplying a by 1/3 to get to y. So in general, no matter what my input is, I know I'll be multiplying it by 1/3 to get to the output. So 1/3 times the input always results in the output. So that would be my equation for this proportional relationship. Now, reminder that the equal sign just says that what's on this side is equivalent to what's on that side, so I could also write this as y equals 1/3 times a. The other key thing to notice here is we're always describing what we're multiplying the input by so that the end result is the output. If we wanted to describe this generally in terms of any input and any output, for a proportional relationship, we know that that input times the constant of proportionality always gives us the output. And we'll recall from the other day that sometimes we use k to stand in for the constant of proportionality. So we could say that if this is a proportional relationship, we're always multiplying the input times k to get to the output. So we could say in general that the constant of proportionality times x, the input, gives us y, the output, for any proportional relationship. Now let's take a look at this idea in a context. In this case, we've got number of gallons of gas used and the number of miles driven on that number of gallons. So to determine if there's a constant of proportionality, we need to divide miles driven by gallons, or the output divided by the input. Now, because we're working with gallons and miles, I need to define a variable to represent each of these two quantities. So at this point, you have a choice. You can use X for the input and Y for the output. You could pick another variable like G for gallons and M for miles. It doesn't matter. The important thing is that you define the variables that you are going to use for the duration of the problem. I'm going to go ahead and use X and Y as we're working through. So X equals number of gallons and Y equals number of miles. So by defining your variable, you let anybody who's looking at your work know which quantity is represented by which variable. So this is gallons, this is miles. So to determine the constant of proportionality, I need to do Y divided by X. So skipping ahead a minute here, I've gone ahead and done the math of Y divided by X, and each time I've gotten 28. So that means that the constant of proportionality equals 28. And what does that mean in this situation? Remember that the constant of proportionality is also the unit rate, so if I add that information to the table, the input is 1, the output is 28. So we could say that for every 1 gallon, you can drive 28 miles. Now, the second step asks us to write an equation that will relate the miles driven to the number of gallons of gas. So remember, we always want to be describing what are we doing to the input, the X, to get to the Y. Well, the unit rate is 28, the constant of proportionality is 28, and if we remember what we said earlier, we always multiply the constant of proportionality by the input to get to the output. Therefore, in this case, we're multiplying 28 times the input, number of gallons, to give us the Y, number of miles driven. And we're still using those same variables as defined up there. So 28 times the number of gallons always equals the number of miles. Based on this equation, we can solve some problems. So how far could this car travel on 18 gallons of gas? So this information we're given is the input, the number of gallons. So if I rewrite the equation, but instead of X, I write 18, then I'm solving that equation for Y, the number of miles we could travel. This is like putting 18 as an input on the table and finding the output. And when we do that math, we get 504. So here's an important note anytime we're working with equations. Right here, you've solved the equation and you've gotten a value for Y. You still need to make sure that you answer the question in a statement to show that you understand what you found and you interpreted the solution correctly. So in this case, that means 504 miles can be driven. So the solution to the equation is not always necessarily the answer to the question, so make sure that you're answering clearly. How many gallons of gas would you need to travel 750 miles? So in this case, we're given the output or the Y value of miles driven. So this means I know that 28 times X gives me, in this case, 750, because I know that 28 times the input gives me the output. And if you'll recall from last year when we're solving equations, we do the same thing to both sides of the equation. So I'm going to divide both sides by 28, and that will allow me to solve for X. And when we've done that math, we get X equals 26.79. This decimal kept going. I rounded it off to 2 decimal points because that's a reasonable amount, especially when we're talking about gallons. And remember, the answer to the equation is not necessarily the answer to the question, so we need to answer the question. Now, realistically, when you're filling up with gas, we don't normally stop at half gallon. So we could say we need about 27 gallons of gas to make sure that we make it the entire 750 miles. And finally, the last question. If you have half a gallon of gasoline left and you are 26 miles from a fuel station, will you make it? Well, we know that each 1 gallon gives us 28 miles. So if we need to go 26, that's going to take us almost a whole gallon. We only have a half, so no, we're not going to make it. We can also know that half gallon would only equal 14 miles, not 26. So in that case, we would not make it to the gas station.